Good morning, folks. I hope you're having a good morning so far. My name is Toki. Once again, it's Toki. I work for the Police Aquarium of Canada as an educator. That means my job is mainly to talk to people about the aquarium and the animals in the aquarium and the science behind the things that happens in the aquarium. Also about the habitat of these animals and animal conservation in general and ocean conservation. Anyway, uh, please join me for a quick land acknowledgement before we get into more details of today's topic. So, Ripley's Aquarium of Canada acknowledges that we are on the traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabe, the Chippewa, the Haudenosaunee, and the Wendat peoples, and is now home to many diverse First Nations, Inuit, and Métis people. We also acknowledge that Toronto is covered by Treaty 13, signed with the Mississaugas of the Credit, and the Williams Treaties, signed with multiple Mississaugas and Chippewa bands. Today, the meeting place of Toronto, also known as the Toronto, meaning the place in the water where the trees are standing, is home to many Indigenous people from across Turtle Island, and we are grateful to work on this land. Okay, um, today, I will be talking to all of you about our upside down jellyfish and also their habitat. But let's focus on the upside down jellyfish first. Before I go any further, I just wanted to mention that if you have any question, feel free to type it in chat. But I suggest you type it near the end or when we're past 10 minutes, just because if you type it too early, I might not be able to see it. That's just how the chat works. I haven't found a way to get past that yet. Maybe in the future I will. Anyway, I would like to start off to obviously these jellyfish, they look very cool, but I would like to start off by sharing a cool fact just to justify as to why I chose to talk about the upside down jellyfish for today. So just to share with all of you, scientists have actually done an experiment recently, and they were trying to understand more about sleeping and the brain. And scientists found that that jellyfish, they actually undergo a resting state. Now, this is cool for a few reasons. Um, One is that jellyfish, they do not have brains, but they do have a bunch of nerves around their head or their bell, which resembles a simple basic brain. And also, I wanted to mention, just so we're all on the same page, sleeping, it doesn't look the same it doesn't look the same throughout the animal kingdom. I actually like to refer to it as resting rather than sleeping, because I feel like resting is a better description. But anyway, um, scientists were actually studying upside down jellyfish to try and understand what the connection is between sleeping and between resting and the brain. And yeah, so they found that they do rest. I find that interesting because even in such an ancient and simple organism like a jellyfish, they still need to rest. I think that's really cool. So scientists look closely at the upside down jellyfish's behavior, and they found that these jellies they would undergo a resting state wherein the pulsing movement that you can see on the screen would actually slow down, and the jellies they would respond less to stimuli while they are in this resting phase. Scientists also found that the upside down jellyfish, when they don't get enough rest, it will eventually catch up to them, and they could end up dozing off during the day. So just like us when we get too tired. Now, um, you might be wondering, or let me just address the I guess the elephant in the room here. Obviously, these jellyfish, they are upside down, and you might be wondering, how does that work? How is that possible? Let's take a quick look at its anatomy. And for this part, I actually prepared a quick PowerPoint slide to help me out, to help me explain or talk about the anatomy. Let me just show that on the screen. There we go. So the upside down jellyfish, they have the same anatomy as any other jellyfish. They have a bell or their head. That's where their nerves would be found, the bundle of nerves. That's also where their digestive their digestive system is. The upside down jellies, they also have tentacles like any other jellyfish. They would mainly use their tentacles for stunning their prey, just like any other jellyfish. And the upside down jellyfish also have oral arms, which, by the way, only true jellyfish have, apparently. The purpose of an oral arm is for catching or for getting food or bringing food towards the mouth of the jellyfish. The mouth of a jellyfish would be in the middle of its tentacles and oral arms, and it's the opening into the jellyfish's bell. Now, so based off of that description, like I said earlier, they have the same anatomy as any other jellyfish. But what changed with their body to allow it to position itself upside down? Well, it would be their bell. Their bell is shaped like a suction cup or a sucker, and the constant pulsing motion that you saw from earlier. Let me just go back to the live jellyfish view so you can see the pulsing motion. There you go. That constant pulsing motion, it actually tends to push out the water that is in between the bell of the jellyfish and whatever they want to stick on. So that constant pulsing motion and the shape of their bell is helping them stick onto substrate. In this case, the substrate would be rocks or tiny pieces of rock. Sometimes they can stick onto sand. And also, apparently, they can swim normally like any other jellyfish, but it just doesn't happen often. Now, there is another benefit to positioning themselves in this way, if that makes sense. Now, if you look at these upside down jellies and their oral arms, or those arms that are sticking out, they are colorful. Now, let me just go back to the PowerPoint slide because I prepared another photo to help us out with this. Okay, so you can see their oral arms. It's very colorful. And actually, you'll see that there are different colors, or their oral arms would look different. That depends on the species of the upside down jelly. It would look different depending on the species. Anyway, their oral arms, there are actually symbiotic algae living in their oral arms. As a quick refresher to our friends here, symbiosis just describes the relationship between organisms. In this relationship, any organism involved, in this case, that would be the upside down jellyfish and the algae. Any organism involved in this relationship would be benefiting from living close to each other. So the upside down jellyfish is providing protection for the algae, and the algae is providing essential food and nutrients for the upside down jellyfish. Food, it gives the upside down jellyfish food. How is the algae able to do this? Well, these are photosynthetic photosynthetic algae. I mean, they are capable of photosynthesis. They can harness energy from the sun, use that energy to produce food for themselves, and also the byproducts of photosynthesis can become food for whatever organism they're trying to feed. In this case, that would be the upside down jellyfish. So yeah, that's one interesting way of eating their food or getting food. Let me just go back to the live jellyfish cam. There we go. Oh, I forgot to mention that Danielle is helping me out today. She is the person behind the live jellyfish cam. Now, it's not these upside down jellies, they don't just eat the food that the algae provides them. They can also eat zooplankton, actually. Zooplankton are microscopic invertebrates that are floating around in the water. They look very similar to insects. I think they look very similar to shrimps, to be honest. Now, they can eat the zooplankton. So you as you can see, they don't really move. But how they eat the zooplankton is that whenever the zooplankton just swims by them, these jellyfish, they can filter them out, or they can try and catch them with their tentacles. And that is, and the zooplankton will just get stunned when they get stuck to their tentacles. One thing you should know about zooplankton is they can't really swim, but they just go along with the currents. They float along with the currents. So the upside down jellies can definitely get access to the zooplankton. Now, I wanted to mention as well that any jellyfish, or most jellyfish, they are known to be able to sting. And these upside down jellyfish are able to do that as well. But for these upside down jellyfish, they do it differently. They do it unusually. They actually they would deploy a mucus net that's filled with nematocysts or the stingers. Basically, these upside down jellyfish can release invisible stinging clouds within a close proximity to them, of course. But it's basically trying to imagine a barrier, basically a stinging barrier that they can emit just a little bit about around them. And I said that these are invisible, and you might be wondering how did we discover this? Well, we discovered this fact because snorkelers would actually report instances of themselves getting stung. They would say that they got stung by something that they did not see. So it's a case of phantom stinging. And when scientists looked more into it, they discovered that these upside down jellies are capable of releasing invisible stinging clouds. So, yeah, they've got a really cool way of defending themselves. They can also use it for catching their food sometimes as well. Now, you might be wondering, where would you be able to find these type of jellyfish? They live in warm waters in the tropics and in the subtropics. In these warm waters, the water should be shallow. Waters in, for example, in mud flats or in canals in the tropics. Also in coastal seagrass beds and mangroves. There's a lot of upside down jellies in mangroves. What would be their predators? Well, that would be any animal that could eat a jellyfish. So that includes juvenile sea turtles in this case, because they live in mangroves or beds or good homes for juvenile sea turtles. You'd also find some adult sea turtles eating them. They're easy food for adult sea turtles. Bigger fish can eat them as well. And also sharks. Some sharks are capable of eating jellyfish. What are the threats to the upside down jellyfish, you might be asking? Well, scientists don't know what could threaten these for now, just because we don't know much about their population. We don't know specifics about their population. But scientists are assuming that whatever could threaten their habitat could also threaten these upside down jellyfish. So I thought it would be nice to focus on habitat loss, specifically the loss of mangroves as a threat to these upside down jellyfish. Friends, if you have not heard of a mangrove forest, it's basically a habitat that's found in the coastal or intertidal zone of a tropical, intertidal coastal or intertidal zone in the tropics or in the subtropical parts of the world, or places that are closer to the equator, basically. And mangrove forests would be really close to coastlines and would be really close to the coastlines, or basically close to the shore. And Danielle is showing us a good view of what a mangrove forest would somewhat look like. Those things that you can see in the back of this tank are supposed to mimic the roots that you would find in a mangrove forest. Every time you go through a mangrove forest, those roots they would be the first thing that you will notice, because the trees and the shrubs. Oh, thank you, Danielle. The trees and the shrubs that would make up a mangrove forest. They have this unusual. They have this very unusual look. They look like they are trees on I think those long stilts. I think is what they're called. What people would step on to look like they're tall. If that makes sense. Why am I even trying to explain it this way? I actually prepared a quick photo for everyone to see, so just so we're on the same page about mangroves. Let me just switch to my PowerPoint slide. So this is a good view, or these are good photos of what a mangrove forest would look like. Well, these are just trees in a mangrove forest, but imagine a really big forest made up of trees that look like this. It's really cool. It's really beautiful. It's very unusual. Now, I wanted to mention that one limitation to mangrove forests is that the trees or the shrubs that make up this type of habitat can only survive in the tropics, so they can only be found closer to the equator. They need the warm temperature. And I wanted to share that historically, mangrove forests were seen as annoying or pesky or as a nuisance by us humans. specifically by land developers or people who would want to develop land, or people who would want to build things. So historically, humans decided to remove or clear these types of habitat to make more land available for developing. Clearly, humans have a knack for acting in the moment without thinking about the consequences for the future. Now, you might be wondering, how are mangrove forests beneficial for our environment and ourselves as well? Well, first, mangrove forests act as a barrier, a natural barrier, to protect coastlines from erosion that's usually brought about by the movement of waves or by wave action. It's also there to protect coastal communities from these things called storm surge, or basically rapid surges of water during a storm or a typhoon. Second, mangrove forests are really good at slowing down the movement of water, which makes them capable of filtering water. And this is important for places where rivers would feed water into the ocean, or rivers would bring water into the ocean. Um, this process of slowing down water, it's really good for promoting sedimentation, or basically it allows sediment or solid particles in the water to settle down in a mangrove forest instead of going into the ocean. And lastly, mangrove forests are really good nurseries for marine animals. They are just a good source of food and shelter. You can imagine you can imagine the shelter that the roots would make. It would be really good for small small larval fish, and then bigger fish would be attracted by those small fish. And yeah, it's one big cycle. It's one big ecosystem. Now, how did the act of clearing or removing mangrove forests affect our environment and ourselves? Well, communities that are situated by the coastline, which we can all agree are highly sought after, and they're economically productive, especially in places that are closer to the equator. These communities are facing the consequences. Man-made climate change is making storms stronger, and climate change is also making these storms occur more frequently in certain parts of the world, and the resulting storm surge, or the water that the storms would bring to the coastline, it's very destructive and lethal. It destroys things, and it destroys a lot of things, and it can kill, unfortunately. Now, these communities that are close to the coastline, they're finding themselves less protected because of the lack of natural barriers, such as mangroves. And sure, some could argue that, well, we can always just build protection. Yes, that's true. But the point that I'm trying to make is, we humans dug ourselves into this particular hole. And instead of clearing and, to be blunt, destroying ecosystems for profit, maybe, just maybe, we could consider caring for our environment. Anyway, to stick to the topic, um, I would actually suggest to revitalize mangrove forests as a natural barrier instead of building artificial ones, because mangrove forests benefits not just us humans but also any organism in the ocean. Anyway, I don't want to end this YouTube live with a rant coming from me. So, if you were wondering how we can help mangrove forests out, and indirectly how we can help upside down jellyfish out, well, I will fall back on one of my favorite suggestions, which is actually to understand that us humans and our actions have consequences to our environment and also to other humans. And also, one other suggestion that I like to share is to try and spread awareness that these are issues that are happening up to today. Mangrove forests are one of the quickest disappearing habitats, or one of the habitats that are quickly disappearing out there, alongside rainforests. And hopefully, in the future, if more people are aware of these issues, then more people can come together to find a solution. But yes, that is it for me. In case you have any questions, feel free to type them in chat. For now, while you guys are thinking up whatever questions you guys have, if you have any, I just wanted to mention that in case you wanted to see more of our live animals, feel free to check out our website, or feel free to check out our website. Um, we do have live webcams connected to different tanks on our website. You would just need to go through our website. This is the website, or that's the URL for the live webcams. Also, I wanted to mention that in case anyone else wants to see how we feed our animals, we do have a few recordings of live feedings for our animals, and they are saved on our YouTube account. So yeah, if you want to see more, if you want to see more of how we feed our animals, feel free to check out our YouTube channel. Let's see. Anyway, I think that is it. I do not see any questions. If you have any questions, feel free to email us and we will get back to you with answers. But yes, that is it for us here at Ripley's Aquarium. I hope you all have a good day, or I hope you all enjoy the rest of your day. Bye, everyone.